Hi everyone, so today I'm going to be going over an example of a definite integral and how we can use U-substitution to find what this is. So just as a review, we're first going to identify what U is, take the derivative of U and solve for dx, rewrite the integral in terms of U, integrate, and then we're going to write our answer in terms of x and then apply FTC. Or we can go back to step 4 and change our bounds and then solve what the definite integral is. So there are two ways that we can go about this problem, and I'll show you both ways of how we can do that. So first I want to identify what my u is going to be. In looking at this problem, my u is going to be the innermost function, which is x squared plus 1. So I'm going to set u is equal to x squared plus 1. Then I'm going to take my derivative. So du is equal to 2x dx. And then we want to get dx by itself. We want to solve for dx. So to do that, we're going to divide both sides by 2x, and we end up with dx is equal to 1 over 2x du. Okay, and now once we're done with these steps, we can make our substitutions. So we have the integral from 0 to 1 x. And since we chose our u to be x squared plus 1, I can substitute that for u to the third power. And I know what dx is. Dx is 1 over 2x du. Okay, so now I can actually rewrite this to see what will happen. And my x's end up canceling out. So I have the integral from 0 to 1 x times 1 over 2x, and this is where my x's cancel out. That's just 1/2, and we're left with u to the third power du. So what I did there, I just brought this term to the front, and that multiplied with the x, and that's how my x's canceled out. So now since I have a 1/2 here, I can actually factor that out in front of the integral. So I have 1/2 in the front times my integral from 0 to 1 du, u to the third power du. Okay, and from here I can find what my integral is. And that's gonna be 1/2 times 1/4 u to the 4th power from 0 to 1. And I just use my integration power rule to find what that is. And from here I can either change bounds, or I can substitute my x back in. So this is where my problem splits into like 2 different ways you can solve this. So the first way is to change your bounds. Notice how my bounds are 0 to 1. These bounds actually go with the integral written in terms of x. So we want to rewrite our bounds so that they match with our u. So in order to do that, we're going to plug in 0 and 1 into our equation up here. U is equal to x squared plus 1. So our upper bound is going to be u is equal to 1 squared plus 1, and that's going to be 2. Our new lower bound is going to be u is equal to 0 squared plus 1, and that's equal to 1. Okay, so now we can rewrite this with our new upper and lower bounds. So I have 1/2 times 1/4 u to the 4th power, evaluated from 1 to 2. Okay, and now I'm going to apply FTC. So 1/2 times 1/4, I'm going to plug in my 2, minus 1/4, plug in my 1, solve what this is. So that's 1/2 times 16 over 4 minus 1 over 4, and that ends up being 1/2 times 15 over 4, and that's just 15 over 8. Okay, and that's our answer to this definite integral here. And what we did was we just changed our bounds. So really we were taking the integral of u to the 3rd power du, but from 1 to 2. Okay, and the second way we can do this is by plugging in our x from this equation and then solving it that way. So I'm gonna copy down this line right here. I have 1/2 times 1/4 u to the 4th power, evaluated from 0 to 1. So we know what u is equal to. U is equal to x squared plus 1. So I can plug that back in. So 1/4 times x squared plus 1 to the 4th power, evaluated from 0 to 1. And we don't have to change these bounds because they were with our integral written in terms of x, and now I have this written in terms of x. And now I can just plug in my FTC. So I'm gonna have 1/2 times 1/4, 1 squared plus 1 to the 4th power, minus 1/4, I'm gonna plug in 0, 4th power, and this ends up being 1/2 times 1/4, and this is just 2 to the 4th power minus 1/4, that's 1 to the 4th power. Keep going, and that ends up being 16 over 4 minus 1 over 4, 1/2 times 15 over 4, and that gives us 15 over 8. So using both ways, we got 15 over 8 as our answer to this definite integral. Thanks for watching.